First up, we're asked to differentiate this expression. Just going to rewrite it as a fifth x plus 3x to the minus 2 minus a quarter. Okay, be careful with this one. It's actually a quarter times 1 over root x. So it's going to become minus a quarter x to the minus a half. We set this up because if you find d by dx, or differentiate x to the n, then you bring the power down and lower the power. Not going to go into details here on why we do that, but that is our rule, and it can be shown using first principles where that comes from. So to differentiate, I'm going to get, just going to write it down here, I'm going to get a fifth minus 6x to the minus 3, and then it's actually going to become plus 1 over 8, because I'm going to do minus a quarter times minus a half, x to the minus 3 over 2. Let me just rewrite that because it looks like I've missed a negative out. Right, I think I'll just leave my answer like that. I don't need to write it as in reciprocal form or with roots again. Okay, I will do, but I think this should be absolutely fine. So it's going to be 6 over x cubed. And this one here is going to be plus 1 over 8. I could either write x to the 3 over 2, or I could write root x cubed, for example. Moving on to the next part, the display area has a rectangular lawn with 2 quarter circles of soil, one on each side, as we can see. The lawn has a length of x meters. That means this is also going to be x meters because we were told that it was rectangular. And each patch of soil has a radius of r. So that means that is also r, as is that one there. The perimeter is 32. I'm asked to express x in terms of r. So let's work out the perimeter. Imagine we're walking along. So P, or yeah, I'll go with P for the moment, is going to be x. I'm actually going to add another x there. So you can walk around the whole shape, or we can do it in several steps like that. And then plus 2r from these two bits. And then I've actually got half of a circle. So 2 pi r is the whole circle. Therefore, it's going to be pi r for half of the circle. And that is equal to 32, as we said. So x in terms of r, well, I can say that 2x equals 32 minus 2r minus pi r. I could factorize out the r, but I'll leave it like this for the moment. Dividing through by 2 gives x equals 16 minus r minus a half pi r. Good. The next part, we're asked to hence show that the area of the lawn is given by this formula. Be careful here, it's only the area of the lawn, the rectangle in the middle we're interested in, not the soil. So that will be base times height. I can then sub in for x using part 1. 16 minus r minus a half pi r times r. So a will be 16r minus r squared minus a half pi r squared. Then using calculus, find the exact value of r for which the area of the lawn is a maximum. So for this, right at the moment, we've got a quadratic. I'm not sure exactly what it's going to look like. It's probably something like this because it's a negative quadratic, but it's going to hit a maximum here where there's a stationary point. The gradient's going to be momentarily 0. So let's differentiate and find dA by dr. 16 minus 2r minus pi r is going to equal 0 for a stationary point. That means that 2r plus pi r is 16. I'm going to factorize out the r. They've asked me for the exact value, so it's going to be 16 over 2 plus pi. That's it, we can't simplify that anymore. Just have to show that it's definitely a maximum, and for this I use the second derivative. So then I'm going to get minus 2 minus pi. This is definitely going to be less than 0, which implies the area will be a maximum when r equals 16 over 2 plus pi. So make sure you do that because it's quite subtle. It does find the exact value for which it's a maximum. It's implying that we also do need to show that it's a maximum. Well done.